Hello, and welcome to Hewlett Packard Enterprise at ISC 2020. I would rather be with you, and I'm sure you'd rather be with me. However, we're going to be doing this virtually, so bear with me. So here at Hewlett Packard Enterprise, we have been asking and answering the big questions as we move into the Exascale era. So my name is Bennett. I have the pleasure of walking you through this presentation, and we're going to talk about how Exascale is completely rethinking how technology comes together, how the convergence of data, bringing together workloads that leverage high-performance computing, artificial intelligence, stroke machine learning, deep learning, and data analytics, how these are going to work together at extreme scale. So we're going to talk about Exascale. We're going to talk about the lessons learnt from our Exascale customers, and we're going to try and offer a little insight into why that's important. As you are probably aware, there are 3 publicly announced Exascale machines. That is Aurora at the Argonne National Lab, Frontier at the Oak Ridge National Lab, and El Capitan at the Lawrence Livermore National Laboratory. These 3 public machines have been purchased by the US Department of Energy, and they're all based around HPE's Cray Shasta architecture utilizing Slingshot interconnect. The Aurora machine will be an exaflop powered by Intel. The Frontier machine will be 1.5 exaflops, as will El Capitan. Both Frontier and El Capitan are based around AMD technology. The underlying Cray Shasta architecture is agnostic to processor and accelerator. But Exascale is not just a machine. It's about an era. It's about the fusion of workloads. It's bringing in IoT, analytics, AI, simulation, modeling. It's bringing them together. And this is going to require a whole new generation of applications. But it also means that we have to stop thinking of these machines as silos. We have to start thinking of these machines as a workflow engine. It's not a machine, it's a system. So here we are, big data analytics, artificial intelligence, modeling and simulation. This is the Exascale era. Our customers are struggling to get the most out of their data. They're struggling to understand what their data is telling them. What mechanisms can we use? Traditional HPC workloads around modeling and simulation are actually very useful for feeding artificial intelligence. Traditional workloads like modeling and simulation provide large amounts of data. If you run these silos, then your workflow is compromised. You want to put this ability of having your data, generating information, understanding information, gathering insight. This requires a new workflow. It's about the convergence of data. Now, within HPE, we talk about the digital transformation. We have massive data growth, and you don't need me to point out all these lovely graphs that have these big kicks that go up to the right that explain, because of all the teenagers on Snapchat, we're getting terabytes of data a day. It's not just that. Every car generates data. Every cell phone generates data. The way things are going, every fridge and washing machine will be generating data. Now, that's not actually a silly thing to say. What we're saying is that there is data everywhere. This data can be useful in context, but it means we need larger models. It means we need new algorithms. The more data we have, the more important it is to be able to get to it, to get to the right data and get to it in a timely fashion. This means trying to understand storage, where it sits. So what are our learnings? speaking to the DOE, as they set the requirements for the exascale machines, they told us we've got to have more flexible software. Currently, HPC software tends to be monolithic. We go back to that silo world. It's complex. They want to add in and understand how AI can be used. So we have to converge HPC and AI. And typically HPC and AI have different system requirements. Because of the power usage, we're going to need greater need of accelerators. And we've just used the word accelerator here, as the Shasta architecture is accelerator agnostic. We need to find the right accelerators in the right amount. And as we move this data around, as we shift simulation data into AI, and as we take data from the field, and as we write data out to make it available to people, we're going to need more mixed I/O and more jobs. We can't just run batch jobs. As we said before, massive data growth. We've got to get the data in the right place within the system. And that's not a machine, that's the system. And we need storage that has speed and capacity. Yes, we'd love to have SSDs everywhere, but we have economic realities to deal with. So what are we doing about it? What are you going to see? You're going to see new software. This new software is going to provide what we like to call a cloud experience. And this isn't today's cloud. This is the promise of what the cloud could be. This is the promise of ease of use. We're going to see converged workflows. We're going to see HPC simulations feeding AI. We're going to see AI helping shape the understanding of the data. We need new compute. We need to have the right processors. We need to have the right type of processor. We need to have the right amount of them connected to the right memories. And we need to make sure that they are interconnected. And by interconnected, we need to talk about between processors as well as to the outside world. We need new storage. We need intelligent data management. We've talked about having the right data in the right place at the right time. There's no point having old data sat on spinning disk consuming watts if you only need it once in a blue moon. But if you do need it, then you don't want to wait for somebody to get a cart, go downstairs, pull a tape out, sorry, showing my age, stick it on a machine and load it up. You want it to be available. So you want data management to be intelligent, you want it tiered, and you want it to be efficient. You want it to be performant. You want to spend the money in the right places. So, simple tagline. We believe that the Exascale era is going to give us systems that perform like supercomputers, but run like a cloud. So what does that mean for the people who are not buying exascale machines? The technology that we use and the systems it generates in the architectures that we deploy, namely the Cray Shasta architecture and the slingshot technology, the learning that goes into taking the technologies and building these systems filters down through our portfolio. We have a wide portfolio, and the software, the interconnects, and the learnings at scale flow down. We'll have industry-leading capabilities. We will have these new technologies, and these systems will be deployed and consumed anywhere. We hope to see you at next year's ISC. Thank you. Stay safe.